Now, it's my great pleasure to introduce Ieuan Carney, if I've said that correctly, from the University of Surrey, who's going to talk about the Jovian-O mission. Thank you.
Thank you very much. So, good morning, everyone. As Dave just said, my name's Ieuan Carney. I'm from the University of Surrey. I'm a PhD student there, but I'm also the leader of the student team for the payloads for Jovian-1 and Jovian-O. So you would have heard a little bit about that from David earlier. But the aim of this presentation really is to take you on the journey of the mission that we've been on recently. So to take you from when the opportunity arose, right through testing AIT to travelling to Oman, what it was like out there, the outcome of that, I won't spoil it right now, but the outcome of that, and then also what we plan to do for the future. So the background for this mission and this project are, we were a group of students from 3 universities that I was leading, from Surrey, Southampton and Portsmouth, under the Jupiter programme, the overarching Jupiter programme. So that's the Joint Universities programme for in-orbit teaching, education and research. So we had the Jovian-1 mission that is still ongoing, which involves AMSAT-UK. And we had this opportunity to launch, we took it, we built the team, and we're doing this really to improve teaching and education in the university. So that's more specifically for the student teams. And part of that was, okay, how can we get students more involved in this? How can we take this opportunity and make it really useful? So obviously we can get some students together to build a very simple payload, but by building a simple payload, we can exercise going through the process, such as the different phase gates, and make our students become more familiar with spacecraft engineering. So in the first year, so we started in about February 2024. Other universities were brought on board in June 2024. And this gave me my first real challenge of having to run a team building session. So I'm only 25 years old, been in academia apart from 1 year in industry. So having to run a team building session was very, very interesting for me. But at the core of it, it was more, okay, how can we familiarize these students that are coming on board with the design and the concept? Because like I said, it was very, very simple. But also breaking down those barriers between engineers of, okay, if we're going to work competently, remotely as a team, how can we set that up? So over the course of the first year, we were facing these challenges, but we did manage to pass our PDR and CDR phase gates. Very, very grateful for the fact that the launch was continually pushed back, which meant that we would have more time to refine our design. But sort of towards the end of the first year, an opportunity came up. And that opportunity was on a rocket launching in Oman with a company called Stellar Kinetics. It was one of their early experimental launches. So there was no guarantee of success. It was suborbital. And it would only give us 10 to 12 weeks to come up with finished hardware to put on this rocket. So I'm sure you'll appreciate that's not long at all for something of this scale or this caliber. Luckily, we had Jovian-1 designs and work in the background. So all we had to do really was just adapt that design, expedite some of the production, simplify it as well to make that possible, and ship it out. We were able to leverage some of our partnerships from Jovian-1. So obviously I'll get into that in the next couple of slides, but AMSAT-UK was one of those, as well as cross-university links as well. And it also gave us a chance to qualify the deploy pod that we wanted to fly for Jovian-1, which was the real main purpose of this mission. Whatever we put inside the deploy pod was a bonus. So this leads me on to the payload that the students and I have been working on for the past 18 months. So very affectionately, our payload's called DAVE, and that stands for Dual Apertures for Viewing Earth. So as you can see in the middle, there's some very rudimentary CAD. Please don't look at it too long or you will notice a few mistakes. But it's basically just a Raspberry Pi compute module with some external peripherals to make it work, such as the CAN controllers, and the connections to the cameras, power in, etc. And then you have your 2 little camera modules there. So initially there were no real stringent attitude requirements for the design. So we were going to have 2 cameras facing on opposite faces of the spacecraft so that we could almost guarantee that with at least one of them we could get a nice view of the Earth. And one of the real benefits of having something like this, and one of the things that I think we did really, really well for this was that we had at least one student from each university working on each aspect of the design. So moving from Jovian-1 to Jovian-O, as I mentioned, what we needed to make this work is actually quite a long list. We needed a completed Dave to act as our payload. We needed an OBC, we needed an RF system, a power system, and a whole CubeSat body. So basically, we needed a whole CubeSat. The jump for this was quite simple. So we contacted people who were working from the AMSAT-UK team on Jovian-1. They very graciously provided a high-power amplifier for our RF system. We took the breadboard/engineering model of our payload for Jovian-1 and treated that as our flight model for Jovian-O. The OBC and RF generation was from a board provided by the Space Centre called Star XL, and then there was also a second payload provided by one of the students who's in the audience as well, that he spent most of those 18 months previously working on as well, which was a deployment camera, so it would capture the actual moment of deployment from the pod. So very, very simply, this is the block diagram and the flow and the operational flow of our CubeSat. It doesn't actually show very well on the on this board, but the gist of it is we were a 3-node CAN bus with a 6-volt and a 12-volt supply line from the power system to power 12 volts to power the RF with a little whip antenna on the top. This was also a 6U, purely just for the deploy pod qualification, but actually, a lot of this could have fit in a much smaller space. And again, just to keep it as simple as possible to ensure that we were as robust as possible, again, working to that 10 to 12 week time frame, our operational flow is boiled down to this, really. Send our deploy cam footage, because knowing the attitude and the dynamics of the deployment is crucial if you're trying to qualify a deploy pod. Then take a photo, collect telemetry, send it all, and just repeat that process over and over. And hopefully in the process of being on a suborbital launch, we get some really, really nice pictures of space, Earth, the rocket, whatever we can get our hands on. Part of the process was building and testing. So you can see a slightly different picture from the one David showed earlier, just a slightly different angle. But we managed to run quite an extensive test campaign for a 4 to 5 week period of time with only 2 people working on it really on any given day. But during the build phase, it was a lot of some students' first time in the clean room, myself included, so that was a really, really great experience. The fact that you can start ticking off firsts before you've even looked at bolting the spacecraft onto a rocket is a huge bonus. Again, we had really minimal time for testing. So by the time we had fixed our designs, found our parts, started to bolt things together and start to test them, we only had about 4 to 5 weeks from the launch window opening. So it was really a struggle to fit everything in that time. So obviously we ran through some basic unit tests, integration testing, and a full AIT regime. We're very lucky that the project lead was someone who had a lot of experience working on space missions, so he was able to lead us and guide us throughout the whole process. And we also, as you can see in the image, managed to get some 3-axis vibe done. We shook to about 60% of what we would expect on the launch, purely because here we're shaking our flight model. We didn't have the time to shake a proto-flight model and then fly something a bit more robust. Obviously, if you've got a spacecraft going up, you need a ground station to collect your data. We did have the option to send our telemetry through them, but we needed much higher data rates than what they were willing to offer us, they being the launch provider. So we had an exchange with AMSAT-UK once again, so thank you very much. Unfortunately, Graham's not here, who provided a bulk of the list of materials. But for myself to receive that, it was very daunting. As someone who has never delved into amateur radio before, it was very eye-opening to just see how simple it can be to just piece some blocks together. And with someone who knows what they're doing on the software, everything can come together very, very nicely. And again, working on that simple but robust design being the most important thing. And you can see down here just how simple the design really is. We also have a very, very nice picture here, which shows our X-Quad Yagi pointed at roughly the elevation we would need for the launch. So if I believe correctly that this was during one of the scrubbed attempts. So this was actually part of our, okay, we've set it up correctly, documentation. So with everything designed and everything working, we were ready to start packing. Another big challenge that you don't typically think about or remember during this is you've got to go through customs when you're traveling, because we had to hand carry this. Again, didn't have enough time. So going through and making a packing list for customs was quite the challenge, because it's a case of, okay, what do they want to know? What don't they want to know? What's actually important for them to know about as well? Because at the end of the day, when I arrived in Oman, the guy opened the box, looked very scared initially, and then he asked, okay, so what is this? The answer spacecraft didn't quite suffice. Eventually, I just said, a computer that can fly. And I think he thought I was taking the mick out of him and just let me go, which was very, very nice. Obviously, as well, because we were going to be so remote, and you'll see just how remote we were in a minute, we had no idea what the facilities were going to be like, and we had no idea of what the local hardware shops were going to be like. So we had to carry a lot of tools with us as well. We had, honestly, enough tools to set up about 2.5 complete workstations while we were out there, even though we would only need one, and we were delivering the spacecraft fully assembled. Better to be safe than sorry. We started this journey on June 20th, and those of you that will remember, there was some issues in the region around then that caused our flight delay in Abu Dhabi to be quite a testy one. So again, we've got 5 people sat in completely different parts of an A380, having to rush them around Abu Dhabi International Airport to make a flight. And eventually I just sort of took it upon myself to just run and then just beg the people at the desk to keep the doors open on the aircraft so that everyone could get through, purely because no offence, Casper, but purely so that I didn't have to then stress about how to get all these people to Oman from Abu Dhabi anymore. Another great part about the travel was the pranks that we would get to play. So we obviously had everything packed the night before, ready to go, come in on Friday morning, ready to pick everything up and get in the taxi, do my final weigh check, and we're 15 kilos overweight. So some very last decisions had to be made in terms of what to dump, what to bring, but it meant that we got to downsize one of our Peli cases. So that was a massive bonus. For those of you that have picked a Peli case up before, they themselves can weigh 10, 15 kilograms. So that saved us the bulk of our weight just by downsizing. But it also meant that the project lead thought we were taking a big Peli case, and instead we were taking a smaller one. So we very quickly had the idea to close the big Peli case that he thought we were taking, zip tie it up as if it was ready to travel, and we left it where everything else was to be left. And it led to a brilliant text exchange a few days later when he came into work. He sent me this picture and said, "Why is this still here?" Luckily, it's not the one that the satellite was in, but still, it gave us some much needed relief in those early stressful days when we were out in Oman. So we've landed in Oman now, in Muscat. As we were coming in, you look out the side of the window and you just see beautiful mountains as you're coming in. Very, very barren. But honestly, one of the biggest takeaways we can say is that Muscat is a beautiful city. It's completely different. I had the privilege of growing up in the region, so it was a little less new to me, but still something completely takes you away with the big cars, the big roads, the mountains in the background, and also the second you step out of the airport, you get hit with a wall of heat, and it's almost takes your breath away from just how hot and how humid it is, but it doesn't stop you from appreciating it. I mean, it's kind of hard to see in the background, but this is a photo of the Muscat night sky or skyline at night. And you can see the mountains in the background, and this was taken from the roof of our hotel. And even when I took this photo, it was still 42 degrees with 80% humidity. It was absolutely ridiculous just how hot it was. So after our one night in Muscat, we had to drive down to Duqm. So Dukham's about halfway down the Omani coastline. It takes 6.5 hours to do the drive. As you're driving down, you pass through about 3 or 4 different landscapes and environments, and each one of them looks like it could be out of Star Wars. It's incredible. You can see just from a few selections of pictures here, these were all taken on the drive down. So these were all within 6.5 hours of each other. And you can see that you can get an appreciation for just how different each one of those landscapes are. And of course, nothing would ever go smoothly. So as we arrived, there was one mega sandstorm occurring, so much so that the trees were sideways, so you can kind of see in the background here a palm tree being blown over, or not blown over, but blown so that it's almost horizontal, sand everywhere, and we, in the lead car, we were about 30 minutes ahead of everyone else, and they wouldn't allow us to check into the hotel until everyone was at the hotel. So we had to brave it in the sandstorm for a little bit, but after a 6.5 hour drive, it was perfectly fine. So we'd think once we get to Dukham, which is still about 2 hours away from the spaceport, everything would be working in our favour. Of course it wasn't. Again, due to the issues in the region, the rocket was delayed this time. So this obviously delays our visits to the spaceport, it delays our integration, but actually, if you spin that, it meant that we had time where everyone was together, which was very, very rare, with students from 3 universities coming together. So we had everyone in the same room who was going to be hands-on with the spacecraft. It meant that we could sit down, go through our procedures, answer any questions, and actually just enjoy the calm before the storm. We knew that once the rocket arrived, we'd be doing 12-hour shifts, a lot of the time overnight to stay out of the heat. So the rocket being delayed actually worked in our favour quite a lot. And this photo you can see in the background, if you can just about make it out, there's a Turkish Airlines cargo plane here. The rocket is actually in the plane in that image. So this was sent through to us to say that the rocket had landed, as we were all tracking it on flight radar anyways, so it didn't really make a difference. But it was nice to have sort of visual proof. So what did the spaceport out in Oman actually look like? So here we can see the launch pad. This was about a week before the rocket had arrived. So this was before any of the infrastructure had come in from the launch provider. But they had accommodation on site, which we got to spend one night in as well, and that was a very surreal experience, spending a night overnight at the spaceport. They had a large integration warehouse where you could obviously work on your payload or your satellite before you bolt it to the rocket. There was catering in a kitchen on site, so we got 3 meals a day, every day, large meals as well. It was just great that we didn't have to spend any money on food in town. And the spaceport as well was a lot more isolated than Dukham. So once again, you'll see in a couple of slides just how isolated we were. The spaceport was another 2 hours outside of civilization from that. So the rockets arrived at the spaceport. As you can see, it's on its crane. So this is the rocket we were dealing with. It was a Stellar Kinetics. It was called Kia-1 after a bird in New Zealand. It was a 2-stage rocket running on propane and liquid oxygen. It was 12 meters tall, aiming for an apogee of 500 kilometers, which got lowered a little bit as time went on. And it actually had active TVC, which was really nice because it meant that we could see that the rocket could, in theory, move to an orbital trajectory. And the feeling, once again, of walking into the integration warehouse one morning and all of a sudden seeing this rocket in front of you, and nothing will ever beat that experience for me personally. It was incredible. One of the beauties of us arriving so early and having that time that we didn't have to worry about our side of things was that we were actually able to get hands-on with the rocket as well. So they needed a few last pieces done. Obviously, as the rocket's in transport, it then needs to be put together on the other side. So we were able to help them with epoxying parts, making composite covers and composite parts for our integration, doing some launch window analysis, and also helping create some test equipment for some bits and pieces they needed to do pre-launch. It also meant that we could help them with the launch pad infrastructure. And this was really, when the rocket arrived, this was really when our daily trips, 12-hour shifts, started at the spaceport. once it was looking like integration was becoming more of a happening a lot sooner, we were able to start doing our mechanical checks. So in this image here, you can actually see me trying to slide the deploy pod into the structure they have in their nose cone. It turns out it didn't fit. We had sent the wrong CAD files over to them, so they were working with slightly outdated CAD files. So it meant that we had to make a few changes last minute, cut a few bits of foam out, put a few bits of new foam in. But we got there in the end. So we were actually able to create these parts, these runners that the CubeSat would slide on, which was very cool, because not only did we then work directly on the CubeSat, we also worked on the interface between the two parts. We also got to confirm the electrical integration, so wiring ourselves up and making sure that the telemetry and the power we received was correct for what we were expecting, for the deploy pod specifically. And we got to run through our own pre-integration checks and procedures. So we had written those out. You'll see some of them later on. We'd written those out, so we were able to run through those procedures, which again was a great first experience for a lot of the people. Unfortunately, with all the delays, you're only granted a 2-week on-arrival visa into Oman. So we had to do a visa run. So we can see down here where Duqm is. We had to drive all the way up to Muscat International Airport. And then we had to quickly hop over to Abu Dhabi and hop back and then drive back down to Duqm. Luckily, there was more than one of us driving. But in total, we had to, in 22 hours, we drove just shy of 1,100 kilometers and just flew just over 800 kilometers. Believe it or not, this was significantly cheaper than just driving to a land crossing, because we would have realistically had to have stayed the night if we were to do a land crossing. But I think my favorite part of this video is you can get a real appreciation for just how much longer the drive was compared to the flight. It really, really was a ridiculous 24 hours in total to leave the car at the airport car park and 6 hours later be unlocking the car ready to drive back having landed. Is, again, one of those experiences that you'll never have again and I'll never forget. So once we get back, it's time for us to run through our integration procedures. So a very, very simple integration plan here. We just made sure that we followed them, did our final ground station testing, which was the most important part for us, really. We did our final arming of the switches, bolting the CubeSat in and then into the rocket, and all in all took us about 3 to 4 hours, which we were really proud of. In rehearsals, it had taken us, just to do one of these parts, it would take us about 3 to 4 hours. So it showed that everyone really had a really good understanding of what they were to be doing at what points. And this image you can see in the background is a team photo actually taken by the CubeSat as part of these procedures. So as part of our final ground station testing, just here in ground station verification, we were getting some images down from the CubeSat, just sat on the workbench, and we thought, why not quickly go and get a little team photo, be a nice keepsake, and this is the photo that came out of it. So from the launch procedures, we learned a lot. I think that's probably an understatement, to be honest. Just seeing how a professional launch provider goes about their business was an unbelievable experience. Getting to sit in mission control, because we needed some sheltered desk space for our ground station. That was, again, being a fly on the wall in that room during some of the decisions they had to make about go, no go, scrubbing launches and anything like that. Certainly not an experience that I'll take for granted anytime soon. And of course, with those high intensity decisions, it becomes a very tense environment. But you could tell that underneath all the tension, there was a real bubbling excitement from everyone in the room as well. So now the outcome. Unfortunately, we missed the launch. Well, you can't really say that because the launch didn't happen in the end. There was an issue with the rocket itself, so there was a plumbing issue. We got 2 launch attempts, both had to be scrubbed. Unfortunately, because we weren't there for the final launch window, all of our equipment, ground station, CubeSat itself is currently sat in New Zealand. Hopefully not in a storage container, hopefully somewhere a bit more friendly to electronics. but it's currently on the other side of the world, so we can't do anything with it at the moment. But we're hoping that Stellar Kinetics can get enough funding to try and launch again, whether that be from New Zealand or from Oman. But we've set it up so that now we can run the ground station remotely, so we won't need to be sending anyone out there again. And also another reason that we missed that last launch window is because we had to drive back from Duqm to Oman. I think we left the hotel at 1 a.m. because we had an 8 a.m. flight. And whoever booked those tickets, it was me. But overall, there was nothing but good memories. We were there in total for 3 weeks, working on the rocket for 2, left to our own volition for 1 whole week as well. We had lots and lots of laughs. We made some seriously good friendships. We only got the cars stuck in the sand at the spaceport once, which was a massive achievement because you can't see a thing at night time over there. Obviously, it was a massive engineering and personal challenge to try and overcome a lot of the problems, especially when I was in charge of 4 to 5 very young engineers out in the middle of Oman with nothing to do, nothing to see but desert. Trying to keep everyone engaged was a challenge, but we got there in the end. We did it and we're all safe. And again, I wouldn't change anything about the experience, apart from maybe the rocket launching. So some photo highlights from the trip. That's the car getting stuck. Here is one of our students who was driving it. Doesn't look very impressed. It probably doesn't help that we may have been yelling a few things out the window at him. But definitely, and then the locals were helping him get unstuck. This is Casper, who had an amazing experience. Casper's just over there. He actually designed the mission patch. So the experience for him getting to put the sticker of the mission patch on the rocket, I can't imagine what it felt like for him, but seeing him be able to do that was, again, just great. A team photo of all of us with the rocket as well. So we don't actually look too tired in those photos. It must have been just as we arrived. But again, just sort of celebrating the fact that we had done it and the rocket was built and our CubeSat was on there. Confirmation of our CubeSat in the rocket. So you can see we've all signed the lid. We've got all of their antennas here. Ours is obviously inside the deploy pod on the CubeSat. This was a selfie we took with the rocket when we stayed overnight. So we had to stay late to continue working on the rocket. So half of us stayed. And we thought, okay, we're probably only going to get the moment to take the picture now. So quickly, let's take a picture so we remember that we spent the night at a spaceport, just in case we never get the opportunity again. And sure as anything, I don't think we touched our phones for the rest of the night. We were so tired and just focused on the work. Very grateful for that picture. And a wider spaceport team photo. So this is everyone that was in Oman that worked on the launch pad, the integration warehouse, the rocket itself, the different payloads, general ground support, catering, everyone, including the Crown Prince of Oman as well. So this is everyone that worked on the program and was at the spaceport. Obviously, when we're waiting for hours and hours for the rocket to launch or get scrubbed, we've got to kill some time in mission control by staying out of everyone's way. So we decided to play some flash games on our computers from when we were at school. And we actually managed to complete one, which I have never had a memory of doing that before, because you normally get told off by the teachers for having them open. And finally, this was the last photo we took before we left the spaceport. So this was after, again, another 12, 13-hour shift. The rocket is about 2 kilometers that way, and it's currently venting all of its fuel. And we've watched the rocket vent its fuel while the sun's rising. Very, very tired. Kevin, who brought a payload from Taiwan, has got far too much enthusiasm there. But we all just sort of want to get on the bus and get back to the hotel and get some proper sleep. But luckily, someone from Stellar Kinetics, chief business officer, I think it was, decided that we should take this photo as a memory. And I'm, again, very, very grateful he said that, because that's probably one of my favorite photos. Anyways, thank you very much for listening to me ramble on about that. I'm happy to take any questions that you may have.
Thanks very much for that. That was a really interesting talk, and I'm glad you got to do a lot more interesting things as a student than I ever did. The spaceport, I think it's ETLAC, isn't it, is on a nice view over the Indian Ocean. There's a lot of spaceport building around the world at the moment. What sort of facilities do they have there? Do you see it expanding rapidly? For example, getting liquid oxygen and propane down into that part of Oman must be really difficult. Did they have a lot of facilities there for that, or was it all tankered in? What do you see the future of the spaceport as?
So it was all tankered in. They do have plans to rapidly expand. So they already have plans for 3 more launch pads there. They've got plans for a business park on site so that you can do a lot more of the design and near integration testing before heading over to any of the spaceports. Duqm itself is a growing town. So it's got an economic free zone there, so they're trying to actively encourage companies to come and build. Land over there costs almost nothing. Cost of living is very low. So there are definitely companies that are looking at that. But I think they want the spaceport infrastructure there before they commit, because otherwise it could be seen as a joint venture and they don't get as much of the benefit. But
yeah, when I see pictures from other rocket constructions or buildings, people are wearing clothes in a clean room and that kind of stuff. Did you have that experience also?
So when we were building our CubeSat, we were full clean room conditions. That's mainly for orbital and long life missions that you would do that. This was a very low. There was nothing really critical in this mission that would require to be fully clean roomed, ESD'd, and clean room ESD'd and gloves. You know, we didn't really need. There wasn't a requirement for it. And if you're working in an integration hangar in Oman, I've got a photo actually of what happened to an office door that was left shut for 3 days. Walked into the office and there was sand everywhere. So unless you've got a proper clean room, there's no point going and taking these extra precautions yourself.
Does that have any influence in your program run in time when you need your clean room in that sense?
Definitely, yeah, because you need to train everyone up that goes into the clean room. Hopefully the plan is now that the people that took part in the future, they don't need as extensive training or familiarization when they walk into a clean room. So it could just be a one-time kind of thing. But definitely, yeah, adding a clean room into the mix makes things a lot more time sensitive. I think you always walk into a clean room, get ready to do your work, and realize you've forgot the one thing that you need straight away. So you have to quickly get out, re-clean yourself before you come back in and clean the object. So yeah, it definitely adds a lot.
Thank you.
Oh, sorry. I'm sorry.
Thank you. I was just curious, did you have to get flight insurance for your payload?
So we were never leaving the rocket, so we fell under the rocket's insurance.
Hi there. First things first, I want to thank you for the beautiful presentation. It was really lovely hearing about that. Now, one thing I know is that one of the largest difficulties in launching a CubeSat is actually the launch provider, actually getting it onto some payload supporter. So how did you come across the opportunity with the Omani rocket?
It's just going to space conferences or expos like Spacecom Expo and talking to people and being willing to take the risk. Knowing that this was an experimental launch, company's second ever launch, the chance of success wasn't as high as it would be if you paid for the launch, is probably the most diplomatic way of saying it. So you just have to accept that risk. A lot of companies wouldn't want to spend the labour costs, materials costs, to know that there's a high likelihood that the CubeSat wasn't going to function. But with a university, you're only really looking at material costs because people such as myself and Casper and the other students, we're essentially free labour. So it takes a big chunk of the cost out. And when you're doing such a simple design, you don't need to spend that much on it. So yeah, our cost was low enough that we were willing to take the risk.
All right, thank you. And just one additional question, if I might. So the equipment's currently in New Zealand, right? So is there any future plans for the CubeSat?
We will be talking to them about that. I'd like to think that they would eventually launch the 2-stage. They do have plans to do other test launches, so maybe it's a case of they just unscrew it from the one and screw it on the other. We don't know. At the moment, they've obviously gone back. They're still in the review process after what happened in Oman and learning from that. So we'll see what happens going forward.
No more questions. Thank you, Ieuan. It's great to see the project going like it did. And from the AMSAT point of view, we've had not quite similar situations. We've been down in the minus numbers with our temperatures. We've been on site in Russia. Thank you very much indeed. And your appreciation, please.